everyone, and welcome to our lesson on the binomial theorem. The binomial theorem is something that's really useful for expanding binomials to higher powers, and it basically says that we're going to follow a number pattern that we'll see in a few minutes known as the PASCAL'S triangle. Let's recall our old method of expanding a binomial known as FOIL. If we've got two expressions that need to be multiplied that have two terms each, we can use the FOIL method, which is multiplying the first two terms, the outer two, the inner two, and then the last. So if I have something like this, x plus 3 squared, I could use that method. What that means is that I've got two of them, so I'm going to need to multiply the first two terms, which gives me x squared, the outer two, 3x, the inner two, another 3x, and then the last terms, which gives me 9. Simplifying, I would put my two x terms together and end with this expression. Pretty simple when there's only two of them. But when I see that I'm going to need to expand and have 3 of the same expression, such as x plus 3 cubed, what that means is I would have to take each group's term and multiply by every other term in every other group. And you can see that that's going to get pretty long the higher the power. For something to the fourth, I would actually need 4 of these. And we don't want to sit and multiply binomials all day. So we have a new method for that, thanks to the binomial theorem, that says that we can follow this number pattern known as the PASCAL'S triangle. You're really going to like this. The PASCAL'S triangle, you can actually create your own if you forget all of these numbers. What it is it starts with 1. It's just a pattern that adds each two numbers above that number and brings it down. So for instance, for the second row, I have a 1 and a 1, and when you add those, you have 2. And each of my rows is always going to start with a 1 and end with a 1. And looking at the pattern here, if I added each number above a certain number, I would have the sum of that number. So 1 plus 2 is 3, 2 plus 1 gives me 3. And you can create your own triangle this way. You don't have to memorize all these numbers. You can see each row adds to give us the next row of numbers. What this is for is expanding. This first row here is something to the power of 0. If you recall, anything to a power of 0 gives us a value of 1. The second row is for anything that needs to be expanded that's the power of 1. Third row is for a power of 2, and so on. So you can use this for any power that is needed. You just need to create your triangle down to that row. Alright, so we're going to try this. We're going to use this triangle to help us expand x plus y to the fourth. So the first thing I want to do is go find the power of 4 row. Alright, and what these numbers are our coefficients for our terms in the expression. So I've got 1, 4, 6, 4, and 1. So first we're going to write those down. 1, 4, 6, 4, and 1. And the next thing you want to do, the terms themselves follow a pattern as well. Our power is 4, so our first term in the expression is going to start on that power and move 1 down subsequently for each term. So my x, and this is going to be a 4, and in this term is going to be a 3, and 2, and 1, and the last one has none. The second term in the expression is going to go backwards. It's going to start with the power of 4 at the end of the expression. So the last one is the y to the fourth. Moving in, I'm going to go down 1 each time. Y to the third, y to the second, y to the first, and then the first term has no y's. And to make sure that you did this correctly, you want to always add up your powers and make sure that they add up to the power on the original expression. So 4, and then I've got 3 and 1, that adds to 4. 2 and 2, that adds to 4. 3 and 1, and then 4. So we are good to go. All of our powers add correctly. This was a positive expression, so all of these are positive. What you want to do is just carry over any sign that's in front of that term. And we did, and all of ours are positive. So our final expression we don't need our 1's, is x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. It would have taken us quite a while to get that if we had to expand by hand, but the triangle helps us get there more quickly. All right, let's try it again. This time let's try an expression that has a number value in it. So if I'm needing to expand 2 plus x to the 3rd power, and I don't want to do it by hand, the first thing I'm going to do is look at Pascal's triangle and find the row that has the power of 3 coefficients. Okay, so that was 1, 3, 3, and 1. And I'm going to write those down. And then remember our other pattern that our 2 terms follow inside. The first one is going to start at the highest number and continue downward. So starting over here with our left term, 2 cubed, 2 squared, 2 to the first, and then no 2's for the last term. And the x does the same thing but starts from the last term. X cubed, x squared, x to the first, and the first one has no x's. Again, we are all positive signs here, so plus signs in front of each of my terms. And you just want to simplify if you do have things that can come together, such as these products of numbers. So let's do that next. 2 cubed gives me 8. 3 times 2 squared is 3 times 4. That gives me 12. 3 times 2 gives me 6. And my last term is just an x cubed. And here's our polynomial expression. And if you wanted to put that in standard form, you could rearrange it going from greatest to least for your powers. All right, so let's see what other kind of shortcuts we can use with our Pascal's triangle. Let's say that we didn't want to actually expand, but we wanted to know how many terms that an expansion would have. Well, thinking about the triangle, we can use that to help us answer that question. X minus 7 cubed. How many terms would be in that expansion? We're just going to go look at the row that would be for a cubed power. So remember, that's 0, 1, 2. Here we are at 3. So I can see right now that there are going to be 4 terms in that expansion. I can answer that question without actually doing that. And also without actually expanding, what would be the second term? You can use your shortcuts to get you there. Remember, the second term would have this second coefficient. It would be 3 in front. And remember the patterns that our terms inside follow. The first one starts with 3, 2, 1, 0. The second one starts 0, 1, 2, 3. So if I'm looking for the second term, my x would be at the squared power, 3, 2, 1, 0. Think about that. And my negative 7, because I'm going to carry the sign with them, would be at the first power, 0, 1, 2, 3. So 1 is my second term on that one. And I just want to simplify what I have. So I've got negative 7 times 3 that can come together. My x squared, and we are all finished. We answered the question without actually having to expand. So this concludes our lesson on the binomial theorem.